Today's vocabulary notes video is going to use in-class 72, which is part 1 of standard 17. There is going to be a lot of vocabulary in today's vocabulary notes video, so make sure you grab your in-class 72 when you have something to write with. Go ahead and fill in information as we go. Standard 17 and 18 and 19 to finish out the school year are all focused on circles. We've done work with circles before, but we may not have had an official definition of what a circle is yet. So a circle is a set of all points that are equidistant from a certain location, which is called the circle's center. Over here in this picture, point A is the center of the circle. And so what happens when we have a circle is that we kind of string together a whole bunch of points that are all the same exact distance away from that center point. And then we could actually come in and put more points in between the ones that I'm putting on the picture here. And then when those fill in together, what we get is this circle, this geometric figure, where everything around the circumference of that circle, the border, is exactly the same distance away from A. We have been using that distance in several different ways already this school year as we've worked through our area standards. So that distance between each point on the circle, so like B, and its center, A, is something that we should already know the vocabulary word for, but just in case you have forgotten, that's going to be that circle's radius. And all of the radii in a circle are congruent. So not only is the distance between A and B equal to R, but this distance here would be equal to R, and this distance here would be equal to R, and any other distance I draw in from A out to the circumference of that circle would be considered R. Moving into standards 17, 18, and 19, we're going to be doing some different things with circles. So not area, but other things related to angles and segments and equations of circles. And so we need to talk through several vocabulary words that are going to be new related to circles. The first of those is called an interior point. I bet you could guess that that is going to be any point that is on the inside of the circle. And then an exterior point is going to be any point on the outside of the circle. When we're looking at points that are on the circle themselves, so like B, C, and D in this picture up here, those can be used to create what we call arcs. We have 3 different kinds of arcs down here. We have major arcs, minor arcs, and semicircles, which are actually arcs. Semicircles are probably what you're the most familiar with because we actually found the area of a semicircle earlier in the year. So a semicircle would be an arc that is exactly half of a circle. We are going to name a semicircle using 3 points, and the 3 points that we're going to use are the end points. Those would have to be on a diameter of the circle, and then we choose 1 point in between those end points so that we know which semicircle we're talking about. So if we had just a tiny little circle drawn in here with a center, a semicircle will be attached to a diameter of the circle, so maybe this is A and that's B. We would need a 3rd point either in the top or in the bottom to be able to name those 2 semicircles. So if we're talking about the semicircle on the top, we would be talking about arc ACB, for example. We put an arc symbol above it. Or if we were talking about the one on the bottom, we could call it arc ADB or BDA. So A and B will be the first and last letters, and then some letter in between that shows which semicircle we're focused on. Minor arcs are going to be arcs that are less than half of a circle, while major arcs are going to be arcs that are more than half of a circle. So if it's bigger than a semicircle, it's a major arc. If it's smaller than a semicircle, then it's a minor arc. Major arcs, we're going to stick with 3 points to name them. So again, like the semicircle, it'll be the end points and one of the points in between. But for a minor arc, we're only going to use 2 points, just the end points. So in this circle up above, let's say, for our examples here, we have two minor arcs we could pick from. Arc CB would be a minor arc, which we could also call arc BC. And then we have another minor arc here between C and D. We know those are both minor arcs because they're less than half of the circle. For a major arc, we would have to go farther around that circle. So maybe we start at C, but instead of stopping at B, we would keep on rotating until we make it all the way around to D, for example. So this arc here, I'm going to use a different color so you can see it, would be an example of a major arc, which would be named then starting with C, ending with D, but passing through B along the way. All right, lots of information about arcs. On the other side of this page, we'll learn how to find the measure of arcs. Moving on with our vocabulary though, we have several words that are related to segments or lines. Chord is the first one of those. A chord is always going to be a segment that has both endpoints on the circle. So if we were to draw a quick picture of what that might look like, we would have a point, we'd have another point, and then that chord would connect them. It does not have to go through the center. It could, but it does not have to. A tangent line, or we could have tangent segments or tangent rays, those are going to intersect a circle at exactly one point. So if we're going to draw a really tiny little tangent in here, we would be able to just touch that circle, but we wouldn't pass through it, and it would just have that one point in common with the circle. Whereas a secant line is a line that intersects a circle twice. So that is actually going to pass through the circle somewhere. It doesn't matter if it goes through the middle or not, but it intersects the circle on the way in, and then it intersects the circle again on the way out. Two more vocabulary words on the front. We're going to talk about central angles, which we did talk about with polygons, so this will be a similar idea. This is going to be an angle that's formed by radii, just like it was with the polygon, and then the vertex is going to be at the center of the circle. So instead of being at the center of the polygon, it'll be at the center of a circle. So if we look back up at our picture at the top, these angles are examples of central angles. Angle BAC, angle CAD, those are both angles that have the vertex at the center and then those radii to form the sides of the angle. And then last but not least, a word that you already know, a diameter is a specific type of chord. Remember, that's a segment with both endpoints on the circle, but that chord has to pass through the center of the circle. So what that means is it's the longest chord possible inside a circle. It's the maximum distance through the circle. All right, in class we will practice some of those vocabulary words. If you want to test your knowledge, go ahead and try to answer these questions before you come back tomorrow, and then when we go through notes, you'll be able to see how well you understood. But for right now, if you would flip to the next page, which I have printed separately in case my ink bled through, we're going to fill in a little bit more information at the top here to round out our vocabulary notes video for today. We're going to learn about arc measure tomorrow. That is going to be the degree measure that's equal to the central angle that intersects the arc. So if we're looking at this circle E example, if I'm dealing with arc AD right here, I'm going to look back at that central angle connected to it. If that central angle is equal to 62 degrees, then so is the measure of arc AD. If I wanted arc BC instead, we're going to go between B and C, making sure it's less than a semicircle. Follow that back to the central angle attached. That angle there is 134, so the measure of arc BC is 134. If we're focused on the measure of a semicircle, since it's half a circle, that'll be exactly 180, half of 360. And then if we had all of the arcs in that entire circle end to end added together, what do you think it's going to add up to? As long as they don't overlap, so we're going to put that in here, 360 will be our total. So try to fill in what these 3 arcs and angles would be equal to before you come back to class tomorrow. We'll check your answers real quick and then we'll do the examples at the bottom. Thanks for watching your vocabulary notes video today. We'll see you in class.